All right, guys, so we're back again from the interruption as usual. Now, as I was saying before, so if you have your gradient and the line is sloping upwards, moving from left to right, you will have a positive value for your gradient. And if you're sloping downwards, moving from left to right, then the value of your gradient is going to be negative. And so just by looking at your signs of a gradient value, you can use that to tell you whether or not it is sloping upwards or downwards, going from the left to right. So that's something to bear in mind when you're thinking about, when you're looking at the signs of your gradient, all right? All right, so moving on. So here we now have an example of a gradient. And so you're going to be doing the calculation for the gradient. Now you want me to write down the formula, so you can use y2 minus y1 over x2 minus x1. All right, so you can go ahead, calculate the gradient. And I want you to use the formula both ways. So but do it this way first. And then now you can check it the other way and see what happens, all right? So when you're through calculating it this way, you let me know and tell me your answer. Raise your hand and let me know that you are finished, and then we look at the answer. Then I'm going to ask you to try the next way and see what you get. All right, so Ms. Waysome is finished. It appears. Ms. Waysome, are you finished?
Yes, sir.
All right, let's just give Ms. Green a time to finish first. Ms. Green, let me know when you're finished. Ms. Green, are you there? Working on it? All right, go ahead. So, Ms. Waysome, what is the answer to your gradient?
3, sir.
Ms. Waysome, sorry.
Yes.
Who did I ask just now? Ms. Green or Ms. Waysome?
Miss Waysome, sir.
Oh, so Ms. Waysome said it's 3. What you got, Ms. Green?
Sir, I got -3/4.
All right, so let me check using it this way. So it means that this, if we label this one x1, y1, and we label this x2, y2, so then what we want to do is take away the y coordinates in 1 from the y coordinates in 2. So we would actually have 1 minus 4. And then now we take away the x coordinates in 1 from the x coordinates. So we would have 5 minus 1. And here we would have in the numerator, we get a -3. And the denominator will get a +4. That was what you got, Ms. Waysome?
No, sir, I got 3. Because sir, what we follow was the y2 minus y1 over x2 minus x1. And then we have 1, 4. And we have 5, 1. So I was thinking that
Just tell me what you did. Let me write what you did.
I just wrote down 4 minus 1 over 1.
1.
Yes, sir. Over 1 minus 1.
over
1 minus 1.
minus 1. What happened to the 5? What happened to the 5, Miss Wilson? You mix up the numbers.
Yeah, I just realized now, sir. So I mix it up.
Yeah, mix up the numbers.
All
right. All right. Quickly do it again, Miss Wilson, and check your answer.
Yes, sir.
So, Miss Green, this is what you got, minus 3 over 4?
Yes, sir.
So what the negative sign here telling you now, Miss Green? What it tells you about the gradient?
Sir, the slope is going to be downward.
From left to right. Don't forget the from left to right.
Yes, sir. So I got it.
Oh, you got it. All right, good. All right, very good, guys. All right, so let me clear this. All right, so here, if you use the formula, you should get negative 3 over 5. All right. Graphically, this is how it would look. Now, when you do those calculations, the x calculation would give you a negative 4. The y calculation would give you a positive 3. And you put the y over x. Now, we use the term rise over run for a way to remember gradient. So the rise is the y value because it is going up vertically. So if you want to think of your gradient is equal to your rise over run. So you can use that as something to drag your memory. So you put the rise on top over the run. All right, so rise would be going up, and run is mean that you're running along the x-axis. All right, so what this really means is y over x. All right, so I hope this can be helpful to you. All right, guys. All right, any question, Mr. Isam?
No, sir.
All right, here we have another example for gradient. I'm going to ask you to go ahead and calculate this gradient. I'm not going to put up the formula. You should know the formula by now. So try and then when you finish, you tell me what you get. Okay, guys, sorry about that. So you finish. Let's wait some what you got.
Sir, 5.
What about you, Miss Green?
Sir, I got negative 1.
All right. All right. So the best thing that you can do when you're doing this is to label your points if you're confused with the numbers. So label one, whichever way you label it. So if you want to label the first one as x1, y1, the other one you would label x2, y2. Now, you could also label them the other, you could put the x1, y1 with the 4 and 1, negative 1 here, and you could put the x2, y2 with the negative 3 and 6. All you need to do is whichever way it's subtracting, you make sure that if you're taking away x1 and the y1, you're taking away those two x and y values from the two x and y values at the other point. So here, using the formula, so our gradient then so gradient would be equal to, and let's take this x away from this x and this y away from this y. Now remember, we start off with the y first. So we're starting off with y1. So we're taking away, so we have minus 1. Sorry, let us start off with y2. So we have y2 here. So that's minus 1. And then we have y1 here, which is 6. So here we have minus 1, but now we are minusing 6. And now for the x value, now we have x2, which is 4. And now we're taking away x1, which is minus 3. So it means that we are minusing a minus. So we have to attach a minus sign. So we're going to put this negative 3 in brackets and then subtract it. So all we need to do here now is to simplify based on our signs. So if you have a negative 1 and you have a negative 6, you have to add these negatively and you get negative 7. Now down here you have positive 4, but now you have a negative times a negative, give you a positive 3. So this becomes positive 7. And so your gradient would be negative 1. All right, what did you get, Ms. Wesa?
Sir, I got 5 over 1. Sir, how you got this 6 to turn negative?
Now, the 6 was already positive when we have it up here.
Yes, sir.
We are subtracting. So remember the formula says y2 minus y1 and x2 minus x1. Now, substitute these values here. So this becomes negative if you substitute the value here. So we're going to put this y2, which is negative 1. We're going to put this 6 for y1, which is 6. But remember, we are subtracting it. And down here now, we are putting the x value, which is the x2 for 4. And then now we have a negative 3 for x1. So we put negative 3 here, but remember now we are subtracting it. So we have to put it like that. So does that explain how we get these signs? Ms. Waysom?
Yes, sir.
All right, Ms. Green?
Yes, sir.
Yeah. What was your answer, Ms. Green?
Negative 1, sir.
Okay. All right, so I guess you are getting it. All right, so let me clear what we have here. All right, so here we use the formula and we get that. All right. Now, graphically, this is what it would look like. Now, based on this one, you notice that your gradient is sloping downwards. All right, now what we're going to be looking at next, let me see how the time is working. We may not have enough time to do much of this, but let me just quickly introduce this one to you. So now we are looking at linear equations. And if you can recall, when we were looking at graph, we use equations to plot a graph. So we have equations that give you straight lines. We have equations that give you curve. Now remember, what we are looking at in this, we are looking at straight lines. So we want to look at equations that give you straight lines. Now, if you look at this equation, y equals 3x plus 7, will this give you a straight line when you plot it, guys?
Yes, sir. Positive values.
Miss Green? Will this give you a straight line?
I guess so.
I don't want you to be guessing on Miss Green. I want you to know. All right, so here I had mentioned some properties of straight line equations. What did I say about straight line equation in terms of the x and y? What did I say about the powers of x and y, guys, for straight line equation? Don't remember? Once you look at the power of y and you look at the power of x, what is the power of y in this equation? What power is y raised to here?
1, sir.
Answer.
1, right. And what power is x raised to?
1, sir.
Right. So once you have an equation where the x and y powers raised to 1, once you plot those, you're going to get straight lines. Right? Remember, when you're looking at a quadratic graph, you have an x with the power 2 in it. So that will give you a curve. But for straight line equation, the x and y will have powers 1. Now, so when you look at this equation, you know it's a straight line equation. Now, but there's something general about this equation. So we're going to look at this equation here. And look at that one. Do you see anything similar with these equations? Is anything similar about these equations, guys?
So they're all at raised to the power of 1.
All right, so you have the y on the left side. You have a number times x on the other side, on the right side. And then you have a number, which is a constant by itself. Now look at this one down here. Can this one be rearranged so that you have y by itself?
Sir, I think so, but you'd have to divide.
All right, so if we are rearranging this, what we want on the left side?
The y.
The y. So what it means, that means that we have to bring this 2x to the other side. So if we bring the 2x to the other side, what's going to happen? We have 3
We'll have 5.
side.
Yes, sir.
All right, let's put this in front. So we're going to have what this 2x going to become?
Minus 2x.
Minus 2x.
Plus 5.
And then we're going to have plus 5. Now, what else do we need to do?
Sir, we're going to use the 3 to divide the 2x.
So we need to
Plus
divide
5.
by 3.
Yes, sir.
Also, we can divide everything over here by 3, or we can divide them individually by 3. It is the same thing. Now this side would cancel with the 3. And then now we only have y on the left side. And this becomes -2 over 3.
2x.
2x over 3 and plus 5 over 3. Right. Now, so this, when you compare to these, it would look the same, right? All right, so all straight line equations have this general look. All right, so if we are to look at the general look, on the left we have a y. On the right we have some number times x. So let's call that number m. So we have some number times x, and we have a number that is generally added. So let's call that c. Now this is the general form of straight line equations. All right. Now in this general form, the m represents the gradient of the line. And the c is the y-intercept. Now that is where the line cuts the x-axis. Sorry, not the x, the y-axis. So the y-intercept is where the line cuts the y-axis. All right, now it is important that you familiarize yourself with this general form, because oftentimes when we're asked to find the equation of a line, this is the form that you would write it back into. All right, so become familiar with the general form y equal mx plus c. All right, let me clear this, guys.
Sir, question before you clear. That one is a new formula for gradient as well?
No, the equation of a line. It's not a formula for the gradient. We already know the formula for gradient, but we are saying that the value in front of the x is the gradient. So in this case, the gradient would be 3. In this case, the gradient is 4. In this case, the gradient is -2. So any number that is multiplying the x when y is by itself on the left side, that would be the gradient. For this one down here, the gradient would be -2 over 3. You follow?
Yes, sir.
Right. So once you see this general form, you must be able to look at these numbers, know what the gradient number is and what the value of c should be, would be a value by itself. So if you look at this equation, then c would be this number 7. C would be 6 for this one, and c would be 5 over 3 in this one. Is that clear? Is that clear, guys?
Yes, sir.
Okay. All right. Now, with that said, as I said, I was just introducing this to you. So I'm going to stop here. And then now, when we meet tomorrow, we will continue with the equation of a line. So that's what we'll be starting from tomorrow. We'll start back from here. All right, guys. So we are going to stop here for now.